Okay, welcome my math fiends. Hopefully you are enjoying this beautiful day if you're in Lansing, or depending on when you're watching this video, maybe you already enjoyed the day. Or wherever you are, hopefully you had a good day and you're enjoying it. I'm just finishing up my first section in my con video, giving you a little report, a little shout out, and hopefully motivating you guys to get started on yours if you haven't already. So this is just a few notes off the top of my head as you watch it, or if you already watched this, a little reviews, kind of what came to my mind. I didn't actually write anything down, but I did look up a couple things because I started watching it yesterday, and then today my mind was a little bit like, wait a minute, what's the difference between explicit and recursive? So here's just a few thoughts that came to me. Number one, we're doing sequences and series. So sequence is just a list of numbers, and there's always going to be a pattern. I think always. There's going to be a pattern in the beginning, of course there's going to be a pattern. And the patterns are very simple in the beginning because we're doing arithmetic. I think that's how you pronounce it. Arithmetic sequences, which simply means you're adding the same number over and over and over again, like 5, 10, 15. You get that? Or you can also be a negative number. It's like it could be 25, 20, 15, 10, right? That's also an arithmetic sequence. You're either adding 5 or maybe you're adding -5, either way. So they're really easy to see, and then they're pretty easy then to create a formula, if you will, to express them. And that way, once you have a formula, you don't have to list the whole number out. You don't have to list it. If I ask you, like, I want to know what's the 50th number in this sequence, you could just calculate it directly once you had a formula. So you can do that recursively or explicitly. And I think, to me, explicitly is better. Not quite. It's my explanation of recursive is not very good yet, but I think it basically boils down to recursive. When you're doing a recursive definition, you have to list like at least one of the starting numbers in the sequence. So to know wherever you are, you always have to know a number that's before where you are to kind of get it rolling. If you do it explicitly, you just build that all into the formula. So I like explicit best. Explicit. Just in case, if you've already done this, should probably mean something to you. If you haven't watched it yet, then this might be a little bit weird. But to do it explicitly, you just look at the first term, whatever it is. So it's always going to be, like, say the first term was 0. It'd be 0 plus the constant, which is, say it's 5. We're adding 5 each time. Plus 5 times n minus 1. And n is like what number you are in the list. So for example, if your list was 0, if your sequence was 0, 5, 10, 15, 20, then using that formula, you'd say, okay, I want to know what the third term is. Well, it's 0, 5, 10. It should be 10. So what's the third term? So the formula we created was 0, because that's the first term, plus 5, that's what's going up by each time, times n minus 1. Well, n, I said, was the third term. N minus 1 is 2. 2 times 5 is 10. 0 plus 10. 10 is 10. That's correct, because 0, 5, 10. 10 is the third term. So hopefully, when you watch it, it makes more sense than just listening to it. But so that was the main thing for the first section, just knowing the difference between recursive, or how to express something recursively versus explicitly, and just recognizing arithmetic sequences and working with a few problems. I'm going to go on to the second one in a moment. That's the sigma notation.